to identify the data set as having a positive relationship, negative, or no correlation. Number of hours a person has driven and the number of miles driven. Positive, negative, or no relationship. Just say out the answer nice and loud. So the number of hours you drive and the number of miles that you drive. Positive, negative, or no relationship? Positive. Because the more hours you drive, the further you go, you've driven more miles. So that would be a positive relationship. How about the number of siblings a student has and the grade they have in math? Unless you're studying at home and they're really loud, there's no relationship. How about the age of a car and its value? Negative? Yeah, it kind of depends on the car. It could be a negative relationship. 90% of the time it is a negative relationship. As soon as you pull it off the lot, it drops by 10%. So this one, I would take either answer. On a test, you would have to explain why, and so then it was either explanation. But certain cars, their value has gone up. Most it's negative. Any questions so far? So for positive or negative, you're looking at the Y value. The first one we talk about is always increasing. The age of the car is increasing. What happens to its value? So this is a dependent variable. Depends on what the age is. The number of songs downloaded on your app. Does anyone know what the iPod is? Forgot to change this because you put it in. The number of songs downloaded on your iPod. That's kind of like downloading on your phone. So if you keep downloading songs onto your iPod or your phone, what happens to the memory? The amount of memory available goes down. So the more you put on there, the more songs on it, the memory goes there. Any questions on positive and negative relationships? Table shows the height and feet of waves at a beach and the number of surfers. Using Excel or Desmos, graph a scatter plot with a trend line and R squared and attach it. So when you're attaching your homework, you want to attach it. If it's in Excel, you can save it and attach the Excel file. If it's in Desmos, you can just take a picture of it. The same thing with Excel. You can just take a picture of it if you're attaching it from your phone. But just make sure I do have the graph with the trend line and R squared. Does anyone have a preference of which one they use? Maybe we'll do both so that you can see both. So when you do your project, you're going to need for the third part a set of data, X and Y values that go together. Someone took the height of waves and how many surfers were at the beach and measured them out. Made the data up, but don't do that. So you enter your data, then you highlight it. Now, for a scatter plot, if you highlight the word, it'll put it in there somewhere, not necessarily where you want it. So you can highlight it or not the word. But you highlight the data, click insert, and scatter plot. Any questions on the graph? Now to get the trend line and arm squared, if you have a plus sign, it works nice there. If you don't, over here it says at chart elements. You should have one or the other. If you have the plus, it's here. You go down to trend line. Notice it puts the line in for you. You go over to this arrow and more options. So trend line, an arrow, more options. And it's right here. Now, depending on which one of these is highlighted, you might need to change it, but you want the one with the bars that works with the graph. And you click right here, equation and R squared. If it's somewhere where you can't see it all, you can use it. You can also highlight it and make the numbers larger if they're too small. Change the title. You just click on it to get the X and the Y axis. You can get it from here. This was height. On Desmos, I don't know that we can put titles and stuff. You need to transfer it to a Word document or Google and then work with it. I haven't tried enough, I guess. Any questions on Excel? Is there anyone that's going to, do you need to see it on Desmos? I'll show you the differences that we. So this is our equation and our R squared. So for Desmos, you want to go to desmos.com. It's a graphing calculator, an online calculator. So it's desmos.com. It has a lot of different graphs and statistics. We learned mean, median, and mode on Excel because it's easier, but they do have it on here. Let me click over here in functions. They have the max, the quartiles. You don't get into standard deviation. But what you have to do is click this, and then you have to have all your data in a list and paste it there. I think it's more time consuming. Now for the scatter plot, click the plus sign and go down to table. So it's a plus sign and table. And then you'll add your data. So you will have for your project 25 pairs of data. It's not showing it because we're only going to 10 and negative 10, and it's like 6 and negative 6. You click on the wrench to change your units. I don't have any negative values. I always start with -1 because then it shows the axis. And then we went up to 6 for X was the largest, so 10's not bad. I always go a little bit larger. And then again, there's no negative values, so I'll go with -1. And the most surfers was 61, so I'm going to go with 65. And now you can see all my points. For the equation, always double check what letters are up here first. We have x1 and y1. If it was x2 and y2, then you have to use x2 and y2. A linear line is y equals mx plus b, so it's y1. It will automatically go in the subscript. Now, instead of an equal sign, next to your 1 on your keyboard is a little squiggly line. You want to use that. And then x1 plus b gives you r squared, which is what we had on the other one, and the equation. R squared 0.9226, which is what we have here. M 9.9459. This goes in extra decimal place. 0.405. So it's the same values. Either one. It's up to you. Whichever is working better with your computer. Any questions on either one of them? Yes. Couldn't hear you. Okay. You're welcome. So everyone understands how to do one or the other. You don't have to do both, as long as you can get one. I think Excel's nicer. You can also do this through Google Slides, but I haven't practiced that, so we'd have to Google it on YouTube, and there's a video. Any questions? I'll leave this one up. Oh. Only because I have to write the equations down. So you will attach a picture of one or the other. Explain how strong a relationship is between the data set using R squared. Well, R squared is 0.9226. that mean there's a strong relationship or a weak relationship? Strong relationship. The closer it is to one, the stronger the relationship. Remember, R squared is between 1 and 0. So the closer it is to 1, the stronger it is. The closer it is to 0, the weaker it is. So R squared is close to 1. So there is a strong relationship between your X and your Y value. X was the height of the waves. And number of surfers. So when you're asked to explain R squared, you look how close it is to 1 or 0. And then you write a complete sentence that uses the words of the problem. Any questions? Explain the slope of the trend. So this is our equation. What value is the slope? And 9.9. Remember, your slope is attached to your X value. I rounded it because it's really close to 10. And it makes more sense. When you're talking about your slope, slope is the change in Y over the change in X. Y was number of surfers. X is the height of the waves. And I think it's 70 minutes. In feet. So explaining the slope, talk about this increasing by 1, because notice we can make this a fraction over 1. So this increases by 1, the number in surfers increases by 10. So each additional how to put waves in there and make sense. Each additional 12. So each foot that the waves increase by, you know that there will be 10 more surfers. So depending on how many lifeguards you need per surfers, You want to find out how high the waves are going and if they're going to keep increasing, and you know when you need to have more lifeguards. So for each additional foot higher that the waves go, the number of surfers increases by 10. Any questions on that? So you definitely need to be able to explain these on a test. Just it for a few weeks. You also need to explain it on your project. So if you have questions, let me know. Well, if the slope is a 9.9, then this is the y-intercept. The y-intercept is when x is 0. So think about what you would write down. Does anyone want to say? I would probably round it to 0 instead of having 4/10 of a surfer. Y-intercept is when x is 0. So we're saying the waves are 0 feet high. No waves, no surfers. Now you could have used 4/10 of a surfer, but it does round to 0. Maybe if it was 0.8, we could have said 0.8 or 0.8 of a surfer, or just rounded it to 1. Someone hoping that a wave would come. Any questions on that? How many surfers might be at the beach if the waves were 2 feet high?
It's about 20.
About 20? Did you plug it into the equation? This is used for estimates. You don't want to go back to the graph and go over to go up and see where it might fall between all those points. This is what the equation's for. So if waves are supposed to be 2 feet high to find the number of surfers, you plug it in here. Remember, X was the height of the waves. Y is the number of surfers. I used the whole decimal when I calculated this, so the decimal might be a little different. Make sure you use sentences for these. I mean, almost all of them we use the sentence except this one. So when the waves are 2 feet high, there's approximately 20 surfers. Any questions on that? I just want to make sure you know how to plot points. We want to plot those points. Okay, so if we plot each of these points, the time on the phone is the X values. Battery life. And I think we had this on the beginning. We said it should be a negative relationship, which means as we're going from left to right, it should be going down. So if we plot the points, the first one is 1, 8. So you go over 1 and up 8 and 5. The next one is 2, 7. So we go over 2 and up 7, and there's our point. 3.5 and 7. So I'm here. 4, 5.3. 6, 5. 7, 3.5. 9. So it looks like graph the points from the data and draw a possible trend line. So when you draw your trend line, it should fall in between your data. So put through the middle of your data a straight line. Any questions on that? Does everyone all right graphing the points? If the trend line is y equals negative 3/4 x plus 9, how much battery life is there after 3.6 hours? So for 3.6, are we plugging it into X or Y? X is the number of hours on the phone. Y is the number of battery life. So if we use the phone for 3.6 hours, should we plug it in for X or Y? And then make sure you end in a sentence. Are you getting 6.3? So there's 6.3 hours of battery life. Any questions? How many hours before the battery runs out? About 8.4. So if the battery runs out, that would mean the battery life is 0. So we'd plug the 0 in for Y. divide for?
Oh, I think I got 12, but I subtracted the 3.6 because I thought it was from that point.
Oh, okay, okay. Yeah, you want to go back to the original equation. Solving for x, we'd subtract the 9 to the other side. And then divide by the decimal. So it takes approximately 12 hours before the battery runs out. Which is a little strange because what's the battery life when it starts? We start at time 0. If we plug in 0 here, when you take your phone off the charger, it has 9 hours of battery. But I didn't make up this problem. But things happen like that when you're working with a trend line. It's an estimate. Any questions on that? Is there any questions on anything? No, positive. Any questions on your project? Start thinking about it now. I mean, it's almost a month away. Well, the homework is due next week, I think. So for the project, there's a file called project. The homework for the project is due November 6th. So not this Sunday, but next Sunday. So start thinking about it. You don't have to get the data. You just have to know what you're going to look for. And maybe do a little research to make sure you can find it. But if you do not have any questions, I'll see you Friday. Make sure you mark the attendance sheet.